In this video, I'll be assembling the RFB development kit. So here I've laid out everything that you'll need for the assembly process. The first step is to install the pumps into the jig. Feed the wires through and make sure that the barbs are facing towards the inside of the jig, towards each other. Then fasten them to the jig. Next, we'll assemble the Arduino case, which is three 3D printed parts. There's a reset pin that you can insert into the case that will allow you to reset the Arduino without removing it from the case. Install the Arduino case on the back of the jig using the provided fasteners, making sure that the cable can exit over the top of the pumps, like so. Then, attach the red wires to the positive connection of the adapter using a screwdriver. Then take the black wires from the pumps, as well as a separate green jumper wire, pinch them together, and fasten them into the negative terminal of the DC power adapter. Then connect this green jumper wire to a ground connection on the Arduino. This is so that the signals from the stepper motor drivers can communicate with the Arduino. Then connect the motor wires according to the specified pinout in the documentation. Okay, jig is assembled with the electronics. Now hook up the USB to the Arduino. Now you can, using the Arduino software IDE, flash the provided firmware to the Arduino. Once that's done, you can connect a 24-volt DC wall power supply to the DC power adapter jack. Then, if you're using Linux, as a root user, launch the MyStat GUI application. This will allow us to control the speeds of the pumps from a PC. So here I have the GUI window open. You can go to the Charge Discharge tab, select the USB device that corresponds to Arduino, connect over serial, and then drag the sliders shown in the lower right of the GUI to adjust the pump speeds. So I'm about to do that here. You can see now the pumps are spinning as that slider goes up to the right. So here I'm adjusting one of the connections to make sure the pumps spin the correct way. We want the pumps to be pumping from the reservoir, from the bottom connection of the pump upwards. Now you can disconnect the power and set the jig aside. We'll now assemble the cell. So there are 4 bolts. It's important that you wrap the threads of the bolts with packing tape or similar to insulate them, to prevent them from short-circuiting the cell on the current collectors. So grab one of the end plates and insert the 4 bolts. Then you can invert it and set it on this cell assembly tool. Then we need to attach the tubing to the box flow frame. So take the 4 short pieces of tubing, cut to length as in the documentation, install them on the flow frames as so. Next, we take the current collector. You can see here I've already attached some bullet connectors to the current collector to connect it to the potentiostat. Place that over the 4 bolts. Then we're going to grab one of these graphite foil inner current collectors, which will actually touch the electrolyte and the graphite felt electrode. So just reorienting that so it's in the middle of the camera. Okay, now we take one of the outer gaskets, which has the square in the middle and 6 holes. And we put that on top of the graphite foil. Next, we take the flow frame with the tubing and insert it with the tubing facing down, going through the graphite foil current collector and end plate. It's a bit of a tight fit, so I mean to use a bit of force, but be gentle with the entire assembly. Then we take an inner gasket, which is a square in the middle and the 4 bolt holes. Place that over the flow frame. We can then put in the first graphite felt into the square hole. Then I'm using, in this case, 3 layers of Deramic 175 separator. This may change depending on the type of separator or chemistry you're testing, but that will go here in the process in any case. Then we take another 4 bolt hole inner gasket, place it over the separator, assembling our sandwich. Sometimes you can use a spacer there if the membrane is very thick to help with compression. Next, we place the other flow frame with the tubing facing upwards over the second inner gasket, followed by our second graphite felt flow-through electrode, and our outer gasket, in this case, is 0.1 millimeter silicone sheet gasket. Then we place our second graphite foil. Mine is a bit beat up in this case because it took me a few attempts to make this assembly video. Normally you wouldn't be removing it and putting it back so many times, but I have been. Then we take our second current collector and make sure the tab on this current collector is opposing the other one. It helps make it easier to connect the potential stat, as you can see. Then we take the final end plate or compression plate and fit it over the entire assembly, getting it slightly compressed. Then hand tighten the nuts onto the fasteners. Now you can remove it. And this is the untightened cell. Then I only had an adjustable wrench, using an Allen key, grabbing it by the skinny end, because this does not require too much torque. Tighten the 4 bolts on the cell progressively, starting with alternating corners. Tighten it hand tight using the skinny end. This is about 2 Newton meters if you have a torque wrench, which is preferable, but it does not take too much torque to tighten this, and if you over tighten it, you can break things. So now we set the cell aside. We can assemble the reservoirs. So these are the 3D printed reservoirs. Note that the 2 barb lengths are slightly different. One is slightly longer than the other. This helps you differentiate the connections inside. So one of the connections drains out from the bottom, and the other one returns the electrolyte midway up the reservoir. This is to avoid kind of short-circuiting the fluid and ensuring good circulation. You want to connect the longer piece of reservoir tubing to the barb that drains from the bottom of the reservoir, and then take the short piece, put in the barbed adapter, and connect this to the part of the reservoir that has the standpipe that returns the electrolyte midway up the reservoir. Now we can insert the reservoirs into the jig as shown, with the long pieces of tubing facing the outside of the jig. Take the long piece of tubing and connect it to the bottom of each peristaltic pump. This is going from the reservoir to the pump. Then insert the assembled cell and connect the flow frame tubing to the outlets or the tops of both peristaltic pumps as shown. Then connect the other end of the flow frame tubing to the reservoir return. This is the barbed adapter on the shorter piece of tubing exiting from or going back to the reservoir as shown. Okay, now you have connected all the tubing to all the components of the cell. It should look like this. All right, now I'm pouring some deionized water into the cell and connecting it back up to the my stack GUI so that I can leak test the cell by running the pumps with water and just observing if the cell is leak tight. So you can see the pumps are running. I do this for at least 5-10 minutes the first time. Just check for any obvious leaks. Pro tip, you can put like a Kleenex or something under the cell to see if it's leaking from the bottom of the cell. Definitely pick up the cell and make sure it's not wet on the bottom or anything. All right. I like to put 2 beakers at the same spacing of the reservoirs. And then you can like empty the electrolyte out like this with the pumps off. And then you can turn the pumps on really slowly and then invert the whole system and like squeeze out the last little bit of electrolyte that is stuck in the tubing in the cell. There you have it.